Pictures of Amsterdam. So as usual, the announcements first. On the back of the room you can find this mobile developer's guide to the Galaxy. There are very comprehensive guides to mobile development for all platforms. They are free, so feel free to get one on the back. We also have our stickers there, and you can also buy a t-shirt if you want. Then another announcement. This evening we are going to have two Meten and Drinken instead of one. There will be the usual one here in Amsterdam and another one in Delft to start our embassy there. So if anybody of you feels like going to Delft, feel free to go. Mike will be there with Judy as well. So and there will be already a contingent from Amsterdam going there. So feel free to go. Otherwise, there is the usual one at Café Bax at 7. Well, we thank, of course, Surstag for hosting our lectures here, as they did in the past. And well, last thing, next week the speaker will be Nick Pello, and he will speak about his new framework for interacting with users and get crash reports on iOS. Okay, so we can start with our lecture today. So let's welcome Peter and Daniel.
All right. Well, welcome. I'm Peter Robinette, and that's me. PR1001 on Twitter, and my website is bubblefoundry.com.
And my name is Daniel Salva. My website is Mackie.nl, and you can find me on Twitter too. So today we're going to talk about mobile APIs, and more precisely about client and server and how they should work together. Let me start a little bit with a story. About 2 years ago, I left the company I was working for, which was Just. Just was a company that was trying to do TV over the internet. There was lots of great technology, but unfortunately it had replicated the TV model a bit too well, and there was never anything to watch. So after that, I was a Mac developer there, and I'd been developing for the Mac for a long time. And at about that time, the iPhone SDK came out, and I jumped headfirst into that. I did a couple of apps, and I'd just done an app called Now, which was about finding interesting art exhibitions to see in Amsterdam. And I did that with a couple of friends, and it turns out they knew Peter. I didn't know Peter at the time. But by the way, Peter, who are you?
Okay. Well, I also have a development background, but kind of very different from Daniel. I studied EU politics of all things, but I've been doing some web development, PHP, that kind of stuff for a long time on the side, and in the last 5 years or so professionally. And like Daniel, it was a big deal when the iPhone SDK came out, because I didn't even have an iPhone, but I thought this is really cool. I want to learn how to make iPhone apps. So I thought, well, the easiest way to learn is to have people teach me. So I'm going to organize an iPhone dev camp. So we were the first outside of the US in end of August 2008, I guess it was. And I had a great time, met a lot of people, really got interested in the iPhone. But still, and even worked on some iPhone projects. But still, I'm still, a web developer, server-side developer. So I had a new project that I thought, okay, I can't do this myself. I need a good, true native iPhone developer, and that's when I met Daniel.
And it all started one day at the Volkskrant Bar. If you've ever been there, there's a very nice restaurant outside on the top of the building. It was not raining that day, and we had lunch outside. And I met with Peter and this other guy, Martin, and they wanted to do an iPhone app as a guide for the Amsterdam coffee shops. Okay, interesting project. And they wanted to have all the information on the server so that it was easy to update, for instance, when the opening times would change or a coffee shop would close or open. But they also wanted to have something so that it could be used by tourists who would typically are not online because they're roaming and they don't want to pay the fees. So that was an interesting problem right there. And Peter would do the server side, I would do the client side, and well, we had to make these work. So we started thinking about it, and when you think about that kind of relationship, there's a lot of ways it can go wrong. You know, there's always this tension between the back-end people and the front-end people, and communication doesn't go so well, and the project gets late, and the blame game starts. Well, it didn't work out that way at all for us. So we're going to tell you how we did it and what we've learned doing that. And just to say, we built this app called Coffee Shopper, which was the guide for the Amsterdam coffee shops. We built it in 2 weeks, everything from scratch, starting the server side and the client side. It was, the few people who tried it loved it. It was a great experience. If you have it on your iPhone, this is what it looks like, one of the screen. If you have it on your iPhone, keep it preciously because it's a collector item. It was in the App Store for exactly 1 week, and then the Apple lawyers came after us and said, no, cannot have this. But basically it had a list of coffee shops, and you could see what was in the neighborhood. There were reviews that people could leave for other users to see. Negative ratings with the little icons. And we were so happy with this project that the next year we did another one together.
And so we thought, okay, what's another great, vice in life? Fast food. And we need a Febo application because you always want to be able to find the nearest croquette. So we went out and said, okay, we've learned a lot. We've got this great platform knowledge. Let's convince Febo to hire us to build their official iPhone app. And so that's what we did. And again, we took a lot of stuff from Coffee Shopper. Okay, very important to find where are the near Febos throughout the Netherlands. We also made some additions. So we now have a menu. You want to know all the products. And you want to know which ones are healthier and which ones are worse. There's the calorie counts in there. So, and download it. You can find out that most of these are around 300 calories per croquette. But there was also something a little bit different. We had... Okay, well, we had a CMS involved. We didn't build the server side entirely from scratch. Febo has a CMS from a Dutch company called WebGenerator. They've been using it, they liked it, all their data was there. Okay, it makes sense that the iPhone app plays nicely with it. They don't have to be using 2 different servers in their day-to-day work. So that was just a different thing we had to deal with, and that also taught us a lot about questions to ask and various performance issues and so on. So that's Febo.
So when you look at this kind of applications, it's pretty common that you have an application that needs to get some data from the server, and there's quite a few out there. But the question you have to ask yourself for the user experience, for a good user experience, is what happens when you're not online? Because let's face it, you're never online all the time. There's always going to be, at some point, you're going to be on a plane, at some point, you're going to be in a dark zone where you don't have a network. So what do you do when you have no internet? Well, if you look at what some big applications out there do, the New York Times, for instance, no internet connection, and you cannot do anything else. Another app, Reddit this time, no internet connection. And yet another one, oops, there was a problem reaching our server. Well, no, I don't think that's a good user experience. That's not what we want. So we thought we could do better than that. And especially keep in mind, our initial problem was we've got roaming tourists who won't be online. So how to approach that kind of problem? You've got a server, a client iPhone app, and you know you can have some connection some of the time, but you don't want to have a, oh, you're not online, sorry, try again later. So let's think a bit about the issues there. First, you have to think in terms of user experience. What do you want to offer to the user? And what is also the context of your project? So ask some questions. We're going to go through a few of those. Then you have to think about what data you need, what data you want to display and fetch from the server. And you want to model this data. You want to represent the data in data structures in your application and on the server, and communicate the data. So that is basically what we're going to talk about today.
Okay, so in terms of questions to ask, this is going to be your basic framework of guiding everything. This is just you probably already can think about this, but we're going to have many apps, mobile clients, communicating through the internet to the server, specifically to the API portion. So if we take that as a given, we can actually start asking a lot of questions about this relationship. How does it work? So go here.
So one first question to ask could be, what is the existing infrastructure that I have to work on? Do we have a CMS? Like in the Febo case, for instance, there was already a CMS, and they wanted to use that. They didn't want to rebuild something. Or do you have to build your own backend because there's nothing, like we did in the coffee shop application? Yeah.
So another question is, are we just reading data from the server? For instance, the Febo app, the iPhone app needs to know from the server the nearest Febos, the restaurants, and the products and news items. But the client doesn't actually send any information to the server. On the other hand, maybe you want to send data. For instance, you saw with the 5 joints, for a coffee shopper, you could, users of the iPhone app could write reviews, and those would get distributed to everyone via the server.
Another issue you have to deal with is how much data and how complex is it? Are you going to have lots of relationships between the data? Are you going to have big tables with joins that you need to deal with? And how much data do you have? For instance, if you're building an iPhone client for Amazon, it's not the same thing as building something for Febo, because Amazon has thousands and thousands, millions probably of products. Febo has about 40. Another question you want to consider is the user mostly online or mostly offline? And we've already answered that a little bit. We know that they're not all the time online. But where is the app going to be used? Is the app going to be used all the time in a place with no connectivity? For instance, if you're in a supermarket and you want an app to get information about products, well, in a supermarket you're not going to have connectivity most of the time. So where is the app used is something important to consider. And of course, are your users roaming? In that case, they will probably not have connectivity most of the time.
Okay, so you've asked all those questions, and now you need to think about showing the data. This is, what are we actually going to show to the user? Because this is the core of it. The server is just to enable incredible user experience in the mobile application.
So the first lesson we learned, and something we decided also for ourselves, is that at first launch, the first experience, it's key, that already, I'm sure, for your app. You want to show some data. You don't want to have, no internet if the user is not online, or please wait, I'm catching up some data from the server. So it's very important to have some data already at first launch. How do you do that? Well, the way I do it typically is preload a snapshot from the server at ship time. When I build the app in the build process, I've got a step that is download a snapshot from the data and embed that in the app. How do I do it in practice? Well, I built a small Mac tool. Why a Mac tool? Because it's easier to run from the command line. There was a time I did that with on the iPhone simulator as well. You can do it there as well. But normally, if you've architected your application correctly, all your model stuff is that what is dealing with the data and fetching data from the server. Well, that should compile as is on the Mac as well as on iOS. So you can just build a small Mac application that reuses that, fetches the data from the server, builds to the store, and puts it in the iPhone app. So that solves one big user experience problem, that you always have something to show. If you download, for instance, the Fable application now from the App Store, it doesn't have the latest data, but it has something to show. Then you need to think about what kind of data you're going to need to display, because that's going to guide you to build a data model. So you can start that just from seeing the screens, basically. Normally you've done your design a bit in advance, and you know what you want to show. So in the coffee shop application, for instance, we know we've got the title, the name of the coffee shop, we've got an image we want to show, a description, location, and all kinds of other information. So you can list all that, and that's the start of your data model right there. Similarly, in the Fable app, we've got also information about the products, we've got a bit more, we've got the price, we've got some indication if some of the logos should be shown. And let me draw your attention here to that share button up there, because that one needs some information that is not immediately obvious from looking at it. Because when you share, this is sharing with Twitter and Facebook, well, you're going to need a URL for that product. And it's not shown anywhere, it's just used for sharing. But you're still going to need that data, and you need to put it in your model. So once you know the data you want, you can start thinking about the data model itself.
And the first step you need to do is to document it. You need to write some documentation. Don't actually try to read this, but this is just a screenshot of a wiki page we made for the Fable app. And this was our Bible. We referred back to this wiki page throughout the process, and we just said, okay, we've documented everything. It's written out partially in plain English up top, but also in a sort of pseudocode of this is the kind of data we have, this is how we use it. And that was really essential throughout the project, and that's something we really want to emphasize that you should do. Have some documentation online that everyone on the team can access anytime. If there's ever a question, you just refer back to there and it should be answered. So, now you actually say, let's do that. Let's represent the data. So, how do we actually store the data on the server? So, we're kind of assuming the server first. With Coffee Shopper, we use Google App Engine and their Bigtable, and then we used Jacob to model the data. But you could also use an SQL database, MySQL, obviously, whatever. Very standard relational databases. And of course, what's hot these days are NoSQL data stores. And those are particularly interesting because some of them are JSON native or very JSON friendly. And we're big fans, as you'll learn throughout this talk, of JSON. So there's a real benefit of just talking JSON end to end.
And on the client side, you need to ask yourself the same question. How am I going to store the data I have? So that depends quite a bit on the complexity of the data you have. And again, what we talked about at the beginning, what kind of relationships between the data, how much data you have. It can be very simple. It can be, suppose you're just showing a list of locations, it can be a pin list. It doesn't have to be very complex. Now, if you want to do some searches maybe on that, maybe you want to use something like SQLite. You can talk to it directly. It's not very hard. Or there's some wrapper libraries out there that you can use. But really, if you want, to go directly and write as little code as possible, you should use Core Data. Really, that's the good choice. It's maybe a bit difficult to learn, but it's good. Now, let's take an example, for instance, to show how we go from the spec to implementation.
So here we have just a very abbreviated form of our coffee shop spec. That screen that you saw earlier is the same kind of thing, where we just say we have a coffee shop, and then among other things we have two properties, a latitude and longitude, and we say these are doubles. So they're numbers with a decimal point in them, 51.60 or something. But this is just a sort of pseudocode. We want to say, okay, take that, let's go to the server. And what do we have? Like I mentioned, for Coffee Shopper, we used App Engine and Django. So we have some Python, but what is in bold here is what's interesting. We actually stored our coordinates, our latitude and longitude, not in the double format that we specified in the spec. We actually used something that was more friendly to the server, what's called a geo-property. However, of course, we have the spec we need to follow, the client's going to expect. So when we output it actually as part of the API, we output latitude and longitude, and we have just some helper formatters. So basically, I think the lesson here is, of course, follow the spec, but don't have it keep you from doing something better internal.
Yeah, I think that's the important point, and the same goes on the client. The spec tells you basically what both will understand. They both know about latitude and longitude. But on the client, well, it makes more sense to use the CL location object, especially since we're going to have to calculate distances and all that kind of thing. So latitude and longitude, yes, we know how to convert from that and to that from location, but internally it makes more sense to use the CL location. So in terms of data structures, what are your choices on the client side? Again, it depends if you use Core Data or not, but you've got a number of options. You can think of, well, do I want to use objects and subclass them? And that requires you to write quite a bit of code, but it may make sense if you've got very complex objects that have their own methods as well. You can think of a catalog of electronic parts, and then they have to calculate all kinds of things. So in that case, you're going to have lots of methods attached to objects, and that could be a good choice. But in most cases, you should be happy enough with just key values. And if you think in terms of storage, how you're going to store that, if you've got key values, it's just basically dictionaries. The advantage of that is that it's very flexible. If things change during development, which happens sometimes, or the spec has to change, well, it's very easy to add or change or remove a field. If you use subclasses, then it's subclasses of NS object, of course. And if you use Core Data, well, you're going to maybe do subclasses of NS managed object. But in most cases, you're going to be just very happy with plain NS managed objects, and then you don't even have to write any code for that.
Okay. And one key thing to think about right away in your spec are JSON types, because often you're going to be, especially in the techniques we're going to show you, you're going to be using them a lot. Even if you know, a coffee shop, I mean, it's not like it's a news article that it breaks at a certain time, but it's still useful. So you need to think of how are we going to represent our JSON types. We need to specify it right away in the specification because it's essential there. So one form is RFC 1123, which looks like this. And this will be a string that you pass around and then you parse it. Another one, also string-based, is ISO 8601, and it looks kind of similar, a little bit different. But if you've done some web development, you've probably seen these at one point or another. And of course, there's also Unix timestamps, and they look like that. And the benefit of them is that you can actually pass them around, not as strings that have to be parsed and so on, but just as numbers, integers, longs, whatever you're dealing with on your platform. So these are all essential things to just make a decision in your spec. All our timestamps or these timestamps are going to be this format, maybe another is this format. The real benefit of these, of course, is that they're much more human readable. This is very nice in debugging. If you say, wait, why am I seeing this? It's not showing up. Oh, right, because the timestamp is wrong. Whereas I don't know many people. If anyone can do this, raise your hand, because I'm very impressed. They could just immediately look at a Unix timestamp and say, oh, that's next week, not this week. But, of course, like I said, the benefit is these are just a little simpler, in my opinion, in terms of processing. But that's you've written your spec, you've got it, you've defined your dates and times, you know what you need to do. Now you need to actually communicate the data. How do we do this? And this is the connection, the heart of the connection between the client and the server, sending the data from the server to the client. So use HTTP, and specifically use REST. So what is REST? If you don't know, it's representational state transfer, and basically it's a concept or a pattern or what have you of how to use the web, or it describes how the web works. And there's some really smart ideas in there that you can use to optimize your relationship, your connection between the server and the client. So basically the basic idea of REST is that you have resources. Normally, when we're talking about the web, this is a URL. And then you have specific representations. So for instance, if we're talking about a coffee shop, that's our resource. But it can change over time. The opening hours change. So each version of that is the representation. And then, I said the opening hours change. That's a state transformation. And for a very nice explanation, just Google for this article, how I explained REST to my wife. It's a really, good introduction to the topic. So I recommend that. And there's some requirements in REST. So we just run through them very quickly. Client server. That's again, the core concept of REST. And of course, we have a mobile app, an iPhone app that we want to talk to a server. Well, boom, we've done that. We're doing that. So this sounds like a good match. A very interesting one, though, is that it's stateless. So the server doesn't know anything about the client. It only responds to what the client asks it. And this is actually really great, especially for mobile apps with unreliable, slow, or dropping connections. As the server, I don't want to have to jump through hoops to say, oh, but he knows this, but not that, so I want to give him this, but no. Just, I don't need to know anything about the client. It just, says, give me this, and I give it to him. He says, give me this if it's changed, and I say, yes, it's changed, no, it's not. So that's really key. Cacheable. We've talked about not having internet connections often on mobile devices. So, the content, the mode of communication needs to be very conducive for the iPhone app to caching. And finally, it needs to be uniform. It needs to be consistent, it needs to be predictable. That just makes your life a lot easier. So, implementing it. So, you have resources for collections. This is, the core thing we do, like this. This is a URL, API, coffee shop. That's our collection. And we also have one for a specific individual coffee shop. So, resource for individual items. For instance, you see now there's the unique ID of the coffee shop appended to the URL. That's that resource. And the other key thing we've talked about with, for instance, coffee shop reviews, you need to also be able to create an item. And the way that we do it in our APIs and our connections is that actually we use the same URL, so the same resource, because we're still dealing with the collection of coffee shops, but rather than getting existing ones, we're going to actually create a new one, and we'll discuss this in a minute. And of course, use this for all the different types. We've talked about coffee shops, we've talked about reviews. In that app, there are also images. We, again, use the exact same patterns. So API/review, API/review/10, so on. And
Yeah. So what we have now, so we've got a way to communicate and basically get information from the server to the client. But remember, we said we already have an application that has data in it. So we're going to need to want some changes. And what we actually want to do is more like a synchronization between the server and the client. We want to make sure that the data that the client knows mirrors the latest that's on the server. So we're going to get updates at regular intervals. But again, we don't want to have the bad experience of the user is doing something and he clicks there and please wait because I have to fetch the latest data. So we don't want to block the user, and we're going to need to do this in the background. So it's a synchronization that happens in the background. And there's a number of ways to do that. You can do it the old-fashioned way with NSThread, and that works very well. But it's much easier if you use something like NSOperation. That's in the most recent version of the OS. Or if you're targeting only iOS 4 and now 5, you can and you should just use actually Grand Central Dispatch, which makes your life much easier. So how do you make those HTTP requests? Because you're in a thread in the background, and you're going to need to grab that data, basically the latest updates from the server. And you need to make those HTTP requests. Well, just use NSURL connection. I know a lot of people, when they start iOS development, look at an NSURL connection, and it's true that you have to learn a few classes around it to actually make an HTTP request, but it's not that hard. And especially what's easy there is that you're in a background thread, so you can do it synchronously. You don't have to worry about the NSURL connection delegate and how you're going to handle that. Just do a synchronous call, you're in the background already, so make it easy. If you have to, there's a number of wrappers around there. ASI HTTP request is a popular one, but really try to use an SURL connection. It's going to be worth your while learning it. And you also have to be aware that if you're using a library, you're making a number of trade-offs. For instance, if you need to customize it, we're going to show you a bit later that we want to use some special HTTP headers. Does your library support that? Is your library going to break with the next release of the OS? So for that kind of thing, really, I think it's worth your while learning an SURL connection. Now, so we've got this data that we need to send, but there's all kind of types there, so we need to serialize them. Well, again, there's one right answer, and we're going to start with that. And Peter gave you the hint already. Use JSON. There's other options, and we're going to go through them. But really, it's the easy way. It's easy to read. It's easy to debug. There's a number of options, many actually libraries on iOS to use that. The one I recommend is TouchJSON. It's not the fastest, but it's one of the fastest, and it's very well maintained, and it comes with a lot of unit tests. So that makes it more trustable in my eyes. Sometimes you cannot use JSON because you're talking to an existing CMS and they don't want to change it, and it's producing, for instance, XML. So you have to deal with that. While it's not ideal, but you can deal with that easily with NSXML parser on iOS. And sometimes you're going to have other formats like binary formats.
Yeah, and just like we said, use JSON as much as possible. But sometimes for very specific reasons, maybe you need a binary format. Binary formats include photo buffers, Thrift, BSON, so on. But you should really only go there if you've really proven that you need that additional benefit. For instance, like we said, it's not human readable. You're going to, again, have to go ahead and get it in the library, so on. And you should really try to stick to JSON as as much as possible.
Hey, I just thought of something. I've got a lot of clients. They give me their data in basically Excel sheets. I can export to CSV based on that. And I could just put my CSV behind an HTTP server. And then, yeah, I don't have to write a database or anything like that.
Well, there's a simple answer to that. No. CSV is horrible. It's not a standard. Never use it. I feel very passionately about this. There's more information on my blog. Again, if you would like to know more about why CSV is absolutely horrible. So, never use it.
Okay, but still, if you use JSON or XML, it's text, so gzip it. It's going to save you a little bit of bandwidth, and since we're dealing with slow networks, it's always good.
Okay. So, we basically set all the groundwork. We know we have some data that we're going to send using HTTP. We've designed our API endpoints. But actually, we now need to make our HTTP connections, our requests and our responses. The request from the iPhone app to the server, which responds. And I'm going to give you a bit of an HTTP crash course, because HTTP is a really great protocol with a lot of actually very powerful things that are already designed that you can just reuse, that you don't, first of all, have to reinvent the wheel, and second of all, then other libraries will understand it, use it correctly, and you'll just work very well. So, first thing, which we saw a little bit already, is HTTP request methods. So, the one everyone knows is GET. You want to get something. That's what you do every day, constantly, when you just type in a URL in the web browser and hit enter. It gets the page. You also actually post stuff. You often do this almost 99% of the time when you fill out a web form and hit submit, hit the button, it's going to post it to the server. And that's traditionally, for instance, in the REST way of thinking, use post, it's a sort of verb here, when you're creating a new item. And when you want to update one and edit it in place, so to speak, use put. So, for instance, I have a coffee shop, and for some reason, let's say I'm allowed to edit it, I'd use a put as my verb, as my method. And there's also delete. So there are a few other even more obscure verbs, HTTP request methods, but these are the four that are essential that you want to use all the time and know about. You also have response status, and again, this is, you've encountered 200. Do you see this? This is this is the standard. You get a page and it comes back. When the server sends it back, it's telling your web browser, okay, it worked, 200. For instance, if you fill out a form and created a new item, it may actually return a 201, and that means created. So all of a sudden, we already have something. The server doesn't need to reinvent the wheel, saying, okay, you gave me some information, and I actually created a new item for this, so yeah, it's new, it's created. Well, we could just say it with the 201 status code. And this is a cool one, 204. No content. Why is this cool? Well, remember, mobile networks are slow and unreliable. The best data to send is no data. So this is really nice. You could just say, for whatever reason they ask for some content, you just say, well, it was a good request, but there's nothing to give you back. So empty responses. And 304 is actually very similar, very important, as you're going to learn in the next few slides. So very similar, but it says not modified. And again, no changes. So for here, we're saying, you asked if this has changed. No, it hasn't. So we don't need to give it to you. We give you an empty response again. And of course, just to round out the list, very important, the 418 status code, which is, of course, I'm a teapot. So, so what we've hinted at all along is dealing with changes. We said this is a synchronization problem. We're synchronizing data between the server and the iPhone app. How do we do this? Well, what's great is that HTTP gives us the tools to do this. We don't have to, again, reinvent the wheel. So we're going to do what's called a conditional request. And this is a nice diagram that just shows how it works. We're going to do a get, like we talked about earlier, but we're going to add a header to our get. We're saying if modified since with a timestamp, an RFC 1123 timestamp. So we're saying, I'd like to get this resource, this representation, if it's been modified since the given date. If not, don't give it back to me. So there's two possible responses from the server. If it hasn't been modified, it just says not modified, no changes. So it's empty, nothing given back. For instance, if I'm getting the whole list of coffee shops. Coffee shops that haven't been touched since last week. Nothing, no change. But if they have, for instance, let's say one of the coffee shops was edited, and we ask for all the coffee shops, it says, yeah, actually it has been changed. Okay, here it is, you get it all back. All, let's say, 40 coffee shops. So this is great. We've, just by implementing this, as you see in our request, it's a very standard request with if modified with a timestamp. And again, we have two different possibilities. By doing this, we've cut down, rather than always getting a 200 with all the data, sometimes we get a not modified with an empty response back. So we can also be more aggressive in our cycle of checking on the iPhone app if there's new data. So we're less likely to be out of date. But the problem is, if one thing changes in our list of 60 coffee shops, the spec says that we need to return all of them. And that sounds inefficient. If only one of them changed, why send them all back? So that leads to an additional optimization called delta encoding. And this is based on an RFC 3229 that is not part of HTTP 1.1.1 standard, but it's pretty, it's moderately well accepted. So this is not maybe as well known, so this is the secret sauce in what we do and what you should do, because we found it works really well. So again, we make a similar request, and we have two possible responses. Not modified, or there's a change. But instead of all of them, you see we only get one back. And that's the key right there. So our request looks very similar. We have an if modified and a timestamp, but we also have this AIM feed header, which what we're saying here to the server, iPhone app is saying, I understand how to deal with a whole list of items. So, and that's what I expect. So if you only have only one or two's changed, then just give me that part of the list. It's for instance like an RSS, and that actually an RSS is the origin of this thinking. And then we have our response. Again, we can get a not modified, nothing's changed, just like before, or we get it says, oh yeah, I can just give you a selection of it. So it returns a 226 header instead of, remember we saw 201, 304, for instance. And it also has a header here, IMV. But, wait a minute, you see also internal server error. What's that? Oops, well. Because, like I said, this is a recommendation, it's a RFC, it hasn't been implemented in the standard. So not all web servers are really going to understand it completely. So we're running, as you see, on Google. We're on App Engine. This is from Coffee Shopper, these examples. And I said, return the 226. It said, okay, I'll return the 226. But Google doesn't know what this is. So rather than correctly putting the right just descriptive text, we saw okay, not modified, those kind of descriptive text. It said, oops, we don't know it, so that we said internal server error. That's annoying, but the important part still got through, 226. So this right here is the heart of what we do, and this is how every time, for instance, you launch the Fable application, it will check for new data. And if something changes, it downloads it. The nice thing is it's not downloading 50 products, 50 coffee shops every single time over your slow, not even 3G, let's say GPRS connection. It only gets, often, most of the time back, 304, no change. And if you'd like to know more, Niels Leher, a guy up in Friesland, wrote a really great blog post on this in 2003. So if you go to rakhas.nl, you can learn more.
So that's really powerful. That's really the heart of that synchronization process we have between the data on the server and the data on the client. But there's a few other things you want to think about. For instance, localization. Especially if you work with Dutch companies, is very often a requirement that your app is going to be both in English and Dutch. Well, that's pretty easy to do for the user interface, right? Apple gives us localized nibs, and we can just do that easily. But that content that you have on the server, how are you going to handle the localization of those pieces of content?
And we do this in several ways. So first of all, again, HTTP to the rescue. There's already a header that you can include in your request from the iPhone called accept language. So you say, these are the languages I support, can you give it back to me? And what's nice, this is an example I just took from my browser, asking Wikipedia, is that you can even list multiple languages. So for here it says, I'd like it in American English, specifically. And if you have that, just any sort of English is fine, if you don't have that. And it's a slightly lower priority. So you could say, I prefer Dutch, but if you don't have that, give me English. If you don't have that, give me German. You can do very nice requests like that. So again, HTTP gives you, in the request, the solution. But there's another issue when we're localizing content on the server, is you actually have to store it. And what are the strategies there of storing them? You could say, I don't want to duplicate data. I want to really, be as efficient as possible. So I'm going to think of some sort of parent and child relationship. So I have some sort of platonic coffee shop, let's say. And this one, it has an address, let's say, because that's always the same, whatever language you're using, and opening hours are always the same. But, the description will be in English or Dutch or whatever. And those will be the kind of the children, in the real world versions of the coffee shop. And, but they all refer to the parent, so they don't have to copy the address. That's one way. Or you can just copy it. And that's actually what we did for iFabo. We actually have not, let's say, 60 Fabo shops in our database. We have 120. And they're all exactly the same, exact same properties, 2 by 2, except the language field will say NL or EM, and of course the translated text. And the benefit of that actually is pretty interesting. On one hand, you have more data to store, but we're not dealing with a lot of data here. But it also means that instead of being very parsimonious and saying, oh, only give me the English data, the iPhone app can just say, give it all to me, and then I choose what to display, the English data or the Dutch data. And that's nice, for instance, if you have a user that is switching languages, their default language on their iPhone. And we did that, of course, to test, but there are also some people that do that just in their day-to-day usage of their phone. Sometimes they prefer things in English, sometimes they prefer it in Dutch, or whatever.
So besides localization, another topic we want to talk about is errors. And errors on the server first?
Yeah, so on the server, again, we have HTTP status codes to the rescue. You guys probably all know 404, not found. This is actually a very valid response from your API. If someone asks for coffee shop 1001 and you only have, coffee shops 1 through 10, 404, you didn't find it. It was, you asked for a bad coffee shop. There's nothing wrong with the server. But sometimes maybe there is something wrong with the server, in which case you'd maybe give a 500 error. So again, you don't have to develop a whole list of errors and try to anticipate everything. You can just, reuse what's already in HTTP. Use the status codes to handle errors. But again, for instance, we saw a 204 or 304 response with no content. Those are actually successes. We didn't want to get content back. It's better when we don't have anything to download. So remember to distinguish between empty responses and errors, where you'd like to give a response but you can't. That's very important.
So that's all nice, but you know, on the client side, I don't care. I'm not going to show errors, you know, to the user because there's no way you can recover from them. Okay, the server has a problem, or maybe you know there's a bug in the app and it's making a wrong request. What can the user do about it? Nothing. So I'm just going to ignore those errors.
Mm-hmm.
Well, to be completely honest, that's not absolutely true, and that's not wasted effort to return the right errors. It's very useful during debugging. There you want to see what the errors are, because of course you're going to do some wrong requests and you want to see exactly what's happening. But when the app is running, you don't care. So you also are going to have to deal with unreliable networks and all kind of weird proxy issues. For instance, you're in a hotel and there's a web page that you need to log in before you can access. Well, again, that's not something I'm going to show the user because they're going to figure it out when they launch their browser. And again, we're talking about synchronization, so it's not key that I'm making a connection to the server. I already have some data to show on the client. I don't have the latest data right. I'm going to be a bit, you know, not at the latest, but I can deal with that. It's better than just getting in the user's way. And just to mention, in Lion, there's an interesting tool called the Network Link Conditioner. I haven't tried it yet, but there's a post by Matt Gemmell, and it allows you to simulate all kind of weird and unreliable wireless connections. So it's definitely worth checking. A few words about debugging. Debugging, with that kind of protocol that we've talked about, debugging is fairly easy because we're using HTTP. That is also what your browser is talking. We're using JSON, which, you know, if you open a JSON link with Safari, well, you see it right there. So you see your text right there. You can just use the browser for debugging and checking, for instance, that you know, you're returning, you're seeing a list of items or you're seeing something else. We've talked about how the REST model gives you a list of things or also direct access to individual instances. Well, in the client, I never use that access to individual instances because I'm always getting a list or, you know, a list with the latest changes. That's what I'm interested in. But for debugging, having access to those individual instances is very useful because you're going to see, oh, but this specific coffee shop is not showing like I expected. And then you can check with your browser and see, oh yeah, that field was filled out wrong. So that is a piece of REST that doesn't seem very useful for coding, but actually it is for debugging. Another thing I usually do is write unit tests for the server. Of course, you should write unit tests for your own code, but very often what happens is that client development and server development happen in parallel. So you're faced with a moving target on the server side with things changing and sometimes breaking, and you want to make sure what is going wrong. So having unit tests for the server saves you some time because you can immediately identify if it's your code or the server that has a problem. And of course, you should have both development and production servers. You're not going to feel the need for that immediately with version 1 of the app. You know, everything is going to be for testing. But once the app is out and you need to push an update and you need to test it, you want to have a development server for testing that is separate from the actual production server that real apps use.
Okay, well, now we're just going to wrap up. So, one thing we emphasized, write a spec. Like Daniel just said, often your mobile and your server development is happening in parallel. So, if, for instance, the thing you want to test or you need to use is not done yet on the other side, you just refer to the spec and you just say, okay, this is what it needs to do. I'll work on that assumption until you can, of course, test it. And then, of course, use standards. We've been emphasizing HTTP and the REST model, but there's also, like we also emphasized, JSON and so on. use standards. Don't reinvent the wheel. I know I'm not smarter than the people that wrote those things. Maybe you are. If so, great. But they work. You know, that way you don't need to write libraries. You just use existing code. It just makes your life easier, simpler. You know, you develop faster. Go for it.
And on the client side, it's the same. Don't reinvent the wheel. There's a lot of good technologies that Apple is giving us, and that make our life really easier. Use core data, use Grand Central Dispatch. It's going to save you time and save you from writing code. And like we said also, when dealing with errors, don't get in the way of the user with things that they cannot do anything about. So try to fail gracefully. And yeah, you're not getting the latest update from the server, but you'll get them next time. So, to finish, what we have to say in one sentence is basically that the user experience depends on what's happening between the client and the server. So if you want a great user experience, you also really need to care about what's happening at the client and server interaction level.
And sorry. Well,
So, Wesley, that
we were doing so well. Okay. Well, basically, at the beginning we said, can they be friends, or should they be friends? And we say yes, they are friends, client and server. When you work so closely together, they're inseparable. So, iPhone loves the server. Thank you.
Thank you.
And if you have any questions, we'll be over there.
Hold on 1 second. We have from our friends at Apple Holland.
Ja, nee. Toch vanavond naar een Indo. Oh nee, net vriendje van de Indo. Hoorde ik al. Nee, dat is inderdaad twee water woord. Waar ben je naar genoeg? Sommige ouders vertellen dat wel. En mijn moeder ik hoorde het via. Ik dacht eerst dat het een van de schrijver was die in de jaren populair was. En iemand tegen op een antiekbeurs. Die ik alleen maar vaag kende, omdat het oh, schattig, je bent genoeg aan mijn eerste vriend.
Ja.
Thank you very much. Well, unfortunately, I didn't bring my connector thing, of course. Sorry, not official, very technology person like you all are. But I'm very happy to be here because I can announce that today we launched another open data contest called Apps for North Holland. North Holland, for those who don't know, is the province of which we are in now. It kind of expands from Amsterdam way up, including one of the islands on top called Texel. Well, there's just for you in the front can see. I'm really sorry about it.
Can't you just put it on his laptop? Sorry to say.
The USB stick.
Yeah, put it on.
Okay.
Or is it cable?
With his permission, of course.
Oh, you have the cable even.
Yes, here you go.
Thank you. Oh ja.
Ja, ik had 4 verschillende adapters. Zo'n mini-USB. De gewone USB die we al hadden. En als je een camera hebt, dan weet je dat er nog 8 zaten dat die USB zijn.
While they're setting that up, I'll remind everybody as well that for our speakers, if you go in the back, we have a little piece of paper you can basically write down just yes or no. If you like the speakers, if you'd like to see them again, that's how we rate things, and
Analog.
yeah, very analog. Then we'll do a bunch of math, add the numbers together, and divide them.
Is it open source?
Just press X. If you just have it playing and the screen's reversed, then you just press the X, and then it will reverse the screen.
Yay! Alright, well, we're a bit off-colored, but what you see here is a very special location we found to organize a code event for you all. Just go to the right. It's here as well. Well, as I told you, another open data contest to be announced. We launched today. You can find it at www.apps4noordholland.nl. We have prizes, as in all regular Apps 4 contests, which are up to 2,000 euros. And we have special prizes for the underdog. And we have some culture and tourism apps prizes, since we have a lot of data on that. And then next there is going to be a selection of 8 app builders for a special program organized by Media Gilde or Media Guild, who are very specialized in teaching, well, guys and girls like you, how to make a commercial success out of your app, basically. Well, the data that's in it is, like I said, a lot of cultural data, a lot of stuff you can see in this province. There is some data from Gemeente Velzen, which is at the coast, about what you can do around there. But there's also going to be data on all traffic accidents that happened and how they ended, like did someone die or not. This kind of stuff is coming up, and we're still working on other interesting data for you as well. I think Lex is going to say something about this as well.
Yeah.
Yeah? Good. Then some important dates today. The start of the contest, then August 27th, which is a Saturday. There will be a code event on this island I just told you about. It's actually a fortress, part of the defense line around Amsterdam, which if you didn't know about, it's also in the data. And we're going to be there all day coding. We're going to have workshops and all fun stuff, but also it's a really, really special place to be around. We are kind of both in love with it. Then the final day to hand in your apps, you can see there, and then on Wednesday the 21st we're going to organize a party to celebrate all the great apps you built and celebrate the first prizes you've won, hopefully. So the event, I just told you, we're on an island. Just in case you have like heart failure or whatever, there is a boat which can bring you back. But for the rest, we just take care of all the necessities, food, drinks and all. And there's no escaping the island. And well, finally, we have been challenged by the province of North Holland, which I am of, Hek Overheid, which Lex is of, Media Guild I just told you about, and Waag Society. And I think Lex is now just going to briefly tell you.
Yeah. So I'm Lex from Hek Overheid, and to put things in perspective, we're co-organizing this event with the province of North Holland, but we have done so in the spring with the city of Amsterdam, which was the app competition Apps for Amsterdam, which resulted in, I think, 48 apps submitted. Crap. Yeah, 48 apps. And I thought it was really cool. We organized it in a Sieraad down here in Amsterdam, and for this, for Hek Overheid, this is really the next level, because first of all, there isn't a lot of province open data around in the Netherlands, and now we can actually have a look at it and see what its value can be for developers. And the other thing is that also the fortress is really an interesting site to do some serious coding. Our Hek Overheid events are always about coding and very little about talking and stuff like that. So yeah, I'm looking forward to meet you guys. Apple developers are very welcome, but also developers from other platforms, different programming languages will be running around, building cool stuff. So, well, I would say that's it, and at Hack the Override, we're very happy to see that this is our second collaboration with the government, as we have been doing hackathons for 3 years. Nobody really cared, so this is a great thing for open data in the Netherlands. So we're really proud with it.
That's it. If you have any questions, just ask, and I do all visit www.appsfornoordholland.nl, please.
Oh yeah, and of course also visit our hacktheoverride.nl, which we're gonna write like reviews of data sets to give you a quick oversight of what kind of data is running around, but it's a lot. And we'll be writing data reviews in both English and Dutch on, well, what is this data set with highways and roadkills, or pollution or noise from school. They have data on that. So we'll be blogging about that, and also we have some GIS experts, or I should say no GIS experts, as they are not really GIS experts, but more 2.0 kind of people who hate the old traditional GIS kind of 5 experts. But they'll be blogging about it, how you can remix the data from KML to shapefiles to, well, all kinds of different data formats which are easy to use for building apps. So check our website, hacktheoverride.nl.
Okay, thank you.
We deden die CMS en was ook
Daniel Salberg.
Alles oké?
geen idee.